Imagine waking up to a world where artificial intelligence is no longer just this really smart chatbot answering your questions.
Right.
Imagine a reality where it's actively, autonomously, actually generating its own scientific hypotheses while you sleep.
It's wild to even think about.
It is a world where AI is powering orbit-level data centers suspended in the actual vacuum of space.
Yeah.
Driving the car that drops you off at work using visual data harvested from, like, teenagers playing Pokémon Go.
Which is still one of my favorite details.
Oh, absolutely.
Wow.
And offering you an explicitly intimate adult mode while simultaneously, frantically trying to calculate the exact psychological moment to cut you off and beg you to go outside and make real human friends.
It sounds exactly like a speculative science fiction novel. I mean, it really does.
Right, but it isn't.
No, it is the literal structural reality of the procurement cycle we are currently living inside.
Mm-hmm.
And it's moving faster than our legacy systems can even track.
Welcome to the deep dive. Before we unpack the Singularity today, make sure to subscribe, tap the bell for updates so new deep dives are delivered directly to you, and give us a thumbs up to help others find our conversations.
Please do.
And this particular deep dive is for all the fans of Dr. Alex Wisner Gross who love his incredible mind-bending contributions on Peter Diamandis' YouTube series, Moonshots.
Yeah, his predictive models and insights into the physics of computation are just, well, they're fundamentally critical right now.
For sure.
We're crossing thresholds that he's been outlining for years.
Completely. And today's mission is to decode his latest Substack post from the Innermost Loop.
Such a good piece.
It's brilliant. It's titled, Welcome to March 17th, 2026. And we're going to explore how the singularity is no longer just theoretical. I mean, it is an economic, physical, and biological reality happening right now.
Yeah, it's around us, it's in our infrastructure, and it's reshaping the very fabric of how civilization operates.
Exactly.
And that is the core theme we need to establish right away for you, the listener. We're moving from an era of human-driven breakthroughs.
Where civilization basically just waits for a singular human genius in a lab to have a random eureka moment.
Exactly. We're moving from that to a reality of machine-driven procurement cycles.
Wow.
So today, we're going to examine the physical hardware powering this massive shift. The software that's now managing human intimacy, the total automation of the scientific method itself, and finally, why the legacy stock market is fundamentally breaking under the sheer velocity of machine intelligence.
Okay, let's unpack this, starting with the physical hardware.
Good place to start.
Because I think there's a tendency to view AI as this ethereal, invisible cloud.
Right, like it just lives in the ether somewhere.
Exactly. But if you want to understand the singularity, you have to look at the concrete, the steel, and the silicon. Nvidia is completely dominating this landscape right now.
Oh, totally.
Jensen Huang is predicting $1 trillion in AI processor sales through 2027.
It's a staggering number.
1 trillion. And what's fascinating is that they aren't just selling chips anymore. They're building the entire planetary ecosystem to guarantee that number.
Yeah, they really are.
They've formed this Numatron coalition, providing DGX cloud compute to partners like Mistral, Perplexity, Cursor, and Black Forest Labs.
Right.
But wait, before we go further, for anyone who isn't tracking the daily AI startup wars, what actually are these companies and why did Nvidia choose them?
It's a great question because this coalition isn't random at all. Nvidia is essentially assembling the Avengers of the open source AI world.
Ah, the Avengers. I like that.
They want to create an alternative to closed ecosystems like OpenAI. Let's break it down. Mistral is the European powerhouse building open-weight language models that rival the best proprietary models.
Okay.
Perplexity is fundamentally reinventing search. Instead of giving you 10 blue links like Google, it reads the internet for you and synthesizes a cited answer.
Which is so much better, honestly.
It's incredible. Then you have Cursor, which is the dominant AI-native code editor that developers are using to write software at light speed.
Right.
And Black Forest Labs is pushing the absolute leading edge of image and visual generation.
So basically, NVIDIA has gathered the top tier of text, search, coding, and visual AI generation under one roof.
Precisely. They're providing these specific partners with DGX Cloud Compute.
Which is what, exactly?
It's basically NVIDIA's ultimate top-of-the-line supercomputing infrastructure accessible over the cloud.
Oh, I see.
Yeah, they use it to build open models directly on NVIDIA silicon. The strategy is brilliant, honestly.
How so?
By heavily subsidizing and supporting the open source layer, NVIDIA ensures that the entire global developer ecosystem remains completely dependent on Nvidia's underlying hardware architecture.
Wow, so it's like Nvidia isn't just selling pickaxes during a gold rush anymore.
No, not at all.
They're figuring out how to manufacture the gold, subsidizing the mining companies, and building the entire planetary crust out of their own proprietary material.
That is the exact economic reality. They are defining the physical laws of the new digital universe.
That's actually kind of terrifying.
It is. And we see this extending deeply into the software stack running on that hardware. Look at Nemoclaw.
Right, Nemoclaw.
This is a framework that wraps the OpenClaw agent platform with intense privacy and security guardrails. Because once you have AI agents taking actions on behalf of humans, security is no longer just about protecting data.
It's about, like, restricting an autonomous entity from taking catastrophic actions.
Exactly. And then beyond the agentic layer, you have something like DLSS5.
Oh, man, the neural rendering. This is huge.
It's massive.
Nvidia is calling this their biggest graphics breakthrough since they introduced ray tracing back in 2018. It introduces a real-time neural rendering model that infuses game pixels with photoreal lighting instantly.
Yeah.
But I want to pause here and make sure we really understand the mechanics of this. What exactly is neural rendering, and why is it a bigger deal than just, making video games look prettier?
We'll understand why DLSS5 is so revolutionary. We have to look at how computers have historically generated images.
Okay.
For decades, we use a process called rasterization. Imagine you have a 3D model of a car. Rasterization basically flattens that 3D math onto a 2D screen, guessing where the light and shadow should be based on simple geometry.
Right, like old school video games.
Exactly. It's fast, but it's a visual trick.
Oh.
Then came ray tracing in 2018, which actually calculates the physical path of individual light rays as they bounce off surfaces.
Which looks amazing.
It looks incredibly realistic, but it requires a staggering amount of mathematical calculation.
Because you're asking the computer to simulate actual photon physics in real time, millions of times a second.
Exactly. It brings GPUs to their knees.
Yeah, for sure.
Now, neural rendering, which is what DLSS5 brings to the table, completely flips the paradigm. Instead of using raw brute force math to calculate the light physics of every single pixel, Nvidia trained a neural network, an AI model, on what photorealistic lighting actually looks like.
Wait, so
now the game engine spits out a lower resolution basic image, and the AI model instantly hallucinates or predicts the perfectly lit high-resolution final frame.
wow. So it's not calculating the light at all. It's using pattern recognition to instantly paint the light based on its training.
Yes. It skips the heavy physics simulation entirely. And why this matters beyond video games is that this exact same concept, using a neural network to bypass complex mathematical simulations, is what is about to revolutionize molecular biology, material science, and weather prediction.
Oh, that makes so much sense.
Right. But to run these kinds of predictive, agentic, real-time models, the hardware itself has to physically mutate. We're shifting from hardware designed merely to train models to hardware designed to run autonomous agents.
And that requires completely different computational physics.
It really does.
Break that down for us. What is the fundamental difference between training an AI and running an AI agent? Like, why do we need new hardware for that?
When you train a model like a massive large language model, you're taking trillions of words and running them through massive matrices of probabilities.
Okay.
You need massive parallel processing. GPUs, graphic processing units, are perfect for this because they have thousands of tiny cores that can do simple math simultaneously.
Right.
It's like having an army of 10,000 people all solving a tiny piece of a massive puzzle at the exact same time. That's the training phase.
Right. Massive parallelization.
But an autonomous agent is different. An agent isn't just generating text based on a prompt. An agent is given a goal.
Like, finding the cheapest flight to Tokyo, book the hotel, and put it on my calendar.
Exactly. The agent has to take a step, wait for the website to load, read the website, decide the next step, execute it, learn from the environment, and iterate.
Wow. Yeah.
This requires incredibly fast sequential logic. It's a linear chain of reasoning. GPUs actually struggle with this because of something called latency.
Latency.
Yeah, it's the time it takes to fetch memory and process a single complex thought before moving to the next one.
Ah, because the army of 10,000 puzzle solvers is great for a massive data dump, but if you need one really smart detective to follow a trail of clues one by one, managing 10,000 workers just creates a bureaucratic bottleneck.
That is a perfect analogy. The friction of an agent actually doing things in real time requires a different architecture. And that is exactly why we're seeing the rollout of these new liquid-cooled Vera CPU racks.
The Vera racks, I was reading about these. 256 custom processors packed into a single rack, specifically designed for reinforcement learning and agentic workloads.
Yep.
So these are basically the detectives you just mentioned.
Correct. They're designed to minimize latency and maximize the speed of sequential reasoning. And we're also seeing the Grok 3 LPX racks entering the picture.
Grok.
Grok is a fascinating company. They built a completely different type of chip called an LPU, a language processing unit. Nvidia is now licensing these Grok inference chips and pairing them with their own Vera Rubin architecture.
Wait, really? Nvidia is licensing from them?
Yeah. The Grok chips act like an ultra-fast toll booth, directing the flow of logic so quickly that the AI can essentially think and react in true real time, much faster than human reading speed.
So we are building specialized physical brains for specialized tasks.
Exactly.
But here is where the scale of this physical takeover gets genuinely surreal.
Oh, yeah.
Apparently the Earth just isn't big enough for this compute anymore. Earth is just like one customer now. Wisner Gross mentions the Space One Vera Rubin module.
Yeah, the orbital data centers.
This is designed to deliver 25 times more AI compute specifically for orbital data centers and autonomous space operations. We are literally launching our machine intelligence into orbit. Why? Is the terrestrial infrastructure bottlenecking that badly?
It is bottlenecking entirely, and it comes down to two absolute limits of physics on Earth: thermodynamics and energy generation.
Right.
Running a massive AI data center generates an incomprehensible amount of heat. On Earth, we have to pump millions of gallons of water through these facilities to keep the silicon from melting.
Right, the water cooling.
But in orbit, you have access to the cold vacuum of space for ambient cooling, and you have access to unoccluded 247 solar power without atmospheric interference.
That is staggering. So we're moving the brains of civilization into space because Earth is too hot and too cloudy to power them.
Basically, yes, it is the ultimate logistical workaround. But for the infrastructure that remains on Earth, that terrestrial bottleneck is forcing explosive innovation.
Because we still have to run things here.
Right. Since we're struggling with the heat and power of pushing electrons through silicon, companies are looking for alternatives. Which brings us to companies like Great Sky. They are launching superconducting optoelectronic networks.
Optoelectronic networks. Okay, explain how this works, because the claims here are unbelievable.
They really are.
They're claiming a million-fold speed-up in video processing over conventional GPUs. A million-fold. The human brain can't even genuinely conceptualize a number like that in terms of practical velocity. How is that physically possible?
It comes down to the fundamental physics of the transmission medium. Traditional chips, like the ones in your laptop or a standard Nvidia GPU, work by pushing electrons through conductive materials, usually silicon or copper.
Right.
When you push electrons through a medium, they encounter resistance. Resistance generates heat. This is known as Joule heating. To make the chips faster, you have to push more electrons closer together, which generates more heat, which requires more cooling, until you eventually hit a physical wall where the chip simply melts.
So electrons are like cars in traffic. They bump into things, they cause friction, and eventually the highway just jams up.
Perfect analogy. Now, what Great Sky is doing with optoelectronics is replacing the electrons with photons, particles of light.
Photons, wow.
Yeah. Photons don't have mass. They don't interact with each other the way electrons do. You can cross two beams of light and they pass right through one another without any friction or interference.
So no traffic jams.
No traffic jams, and crucially, practically zero heat generation from resistance. Because they are using light to compute and communicate data, they can operate at the speed of light, processing massive amounts of data, like ultra-high-resolution video at 1,000,000 times the efficiency of an electronic chip.
That is insane.
And they use significantly less energy to do it.
But even with light-based chips on the horizon, the sheer power demands of the hardware Singularity right now today are staggering.
Oh, absolutely.
And that explains the massive innovations we're seeing in power infrastructure to support all this silicon. It's not just about the chips, it's about the batteries. Midwestern power grids are currently running first-of-their-kind pilots with sodium-ion batteries that are cutting stored energy costs by roughly half compared to lithium.
This is a critical pivot for the global supply chain. For the last 20 years, the entire mobile and electric vehicle revolution has relied on lithium-ion batteries. But lithium is finite, it's expensive to extract, and it's geopolitically incredibly complex to secure. Sodium, on the other hand, is literally one of the most abundant elements on the planet. It's in the ocean. It's everywhere.
Well, if you want to power the singularity, you can't rely on rare earth minerals. You need grid-scale storage that is cheap, ubiquitous, and chemically stable.
Exactly. If we're going to build data centers that require the electrical output of a small nuclear reactor, we need a way to store that power during peak generation times and deploy it constantly.
Makes sense.
Sodium ion is heavier and less energy dense than lithium, so you might not want it in your lightweight smartphone. But for massive stationary data centers, it is the holy grail of cheap energy storage.
And if you can't build a massive new grid fast enough, the market just forces the grid to come to you.
Yeah, look at China.
Right. In China, they are taking a totally different approach to power delivery. They're deploying these 100 kilowatt-hour charging robots.
I love these things.
They're essentially autonomous battery banks on wheels. They just roam around parking lots, track down electric vehicles or mobile compute stations that need juice, and plug themselves in.
Yep.
They're turning literally every parking space into a dynamic mobile power bank. The infrastructure is adapting dynamically to the energy demands of the machines. But this constant, insatiable need for power and space brings us to a mind-blowing statistic from the real estate sector.
This is where the physical world is visibly transforming.
For the first time in history, United States construction spending on data centers, which hit $3.57 billion, has officially surpassed office construction, which sits at $3.49 billion.
Wow.
The data center is now civilization's dominant building type.
I really want you, the listener, to think about the deep sociological implications of that single metric.
It's massive.
For the last century, since the Industrial Revolution fully transitioned into the knowledge economy, the skyscraper, the downtown high-rise, the suburban office park, these were the physical manifestations of human economic output.
The temples of human capital.
Exactly. They were where we went to generate value. The fact that data centers have eclipsed them means the physical architecture of our civilization is explicitly reflecting a new reality.
Which is what?
The generation of economic value is shifting from human minds to silicon cores.
It is a profound architectural marker of human history. I mean, Meta alone is committing up to $27 billion over 5 years to Nebius for dedicated AI infrastructure.
Yeah.
OpenAI is entirely pivoting their Stargate project. They were originally going to build their own massive data centers, but the urgency is so high that they're shifting to renting cloud servers to rapidly accelerate their deployment.
They have to.
And to fund this, they're courting massive private equity firms, TPG, Advent, Bain, for a $10 billion enterprise AI venture.
And the strategy behind that private equity move is absolutely brilliant from a corporate survival standpoint. OpenAI isn't just raising capital to buy more Nvidia chips. They're building an entrenched distribution network.
How so? Connect the dots on the private equity angle.
Think about what a private equity firm is. Firms like Bain or TPG own massive portfolios of legacy companies, retail chains, manufacturing logistics, legacy software providers.
Okay.
These legacy companies are currently terrified of being disrupted by AI. By partnering with these private equity giants, OpenAI gets the $10 billion they need for compute, and in exchange, OpenAI becomes the exclusive integrated AI provider for the hundreds of companies within those private equity portfolios.
Oh, wow.
Right? They are offering a digital lifeline to legacy corporations while simultaneously locking in a massive guaranteed enterprise customer base.
It's an aggressive, brilliant monopolization tactic. But I have to push back here. I want to look at this from the perspective of the individuals.
Sure.
If data centers are physically replacing offices precisely because AI is automating the administrative, cognitive, and analytical jobs that once filled those offices, aren't we just building giant silicon monuments to human obsolescence?
It's a dark way to look at it, but...
I mean, where do you, the listener, fit into a world where Earth is just one customer for orbital AI compute, and your downtown office building is being replaced by a windowless, liquid-cooled server farm?
It is the defining existential question of our era. And the honest, uncomfortable answer is that we're in an incredibly volatile transitional phase.
Yeah.
The physical footprint of AI is overtaking human workspaces because the software running on this hardware is simply becoming vastly more capable, faster, and cheaper than human labor in specific cognitive domains.
It's happening so fast.
The transition is violent, economically speaking. We are rapidly building the infrastructure for a post-labor economy, an economy where intelligence and output are decoupled from human hours worked, but we are still completely trapped inside a labor-dependent society, where you need a job to pay for your housing and food.
And the sheer velocity of this intelligence explosion is so overwhelming that the companies building the tech can't even afford to pause and figure out the societal impact.
No, they can't. They're in a race for survival. Even the top AI companies are being forced into massive strategic triage. They have to decide what matters right now, today, to secure their dominance, because the ground is shifting beneath them every week.
Exactly. And that triage brings us directly into the software side of the Singularity.
Let's talk about the software.
So let's look at how that triage is manifesting at OpenAI. Top executives there are frantically pivoting their focus. They're pointing the entire ship toward coding and business users.
Yep.
Fidji Semo, who is the CEO of applications at OpenAI, explicitly told her staff that Anthropic's recent successes should serve as a massive wake-up call.
When a company that is leading the absolute frontier of artificial intelligence, a company that basically triggered the entire generative AI boom, tells its staff they need a wake-up call, you realize how ruthless the procurement cycle has become.
Right.
The competitive moat in AI isn't the underlying algorithms anymore. The underlying math is becoming commoditized. The moat is utility. It is integration. It is how seamlessly your model can actually do the work for a business.
And OpenAI's pivot to pure utility is working. Their Codex model, which is their specialized AI for programming, has hit 2 million weekly active users. That is up nearly 4 times since just January.
That's incredible growth.
And their enterprise API usage jumped 20% immediately after the GPT 5.4 launch. They're successfully locking down the developers. If you own the developers, you own the future of software.
Absolutely.
But alongside this ruthless, hyper-efficient enterprise focus, there is a totally different, incredibly strange, and deeply psychological social pivot happening within the exact same company.
This is where the intersection of corporate economics and human psychology gets incredibly volatile.
OpenAI is preparing what they are officially calling an adult mode for ChatGPT. This is a mode that will explicitly enable sexual, romantic, and deeply intimate conversations with the AI.
For a company that has spent years applying incredibly strict, almost puritanical safety guardrails to their models, to suddenly open the floodgates to explicit intimacy is a massive paradigm shift.
Here's where it gets really interesting, though, because they aren't just taking the brakes off completely. It's the new guardrails they're putting on it that are fascinating.
Right.
OpenAI is deliberately, actively training these adult mode models to not encourage exclusive relationships with the user. Using reinforcement learning, the AI is actually programmed to occasionally push back.
Yeah.
It's designed to remind people that they need to go seek out human relationships in the real world.
It is a remarkable attempt at engineering emotional detachment into an entity designed for ultimate engagement.
It really is. It's exactly like a bartender who serves you the absolute strongest, most perfectly mixed drink in the world. A drink tailored perfectly to your specific brain chemistry, your specific desires, and your exact mood that evening. But then, right when you're feeling the absolute best, the bartender physically cuts you off, hands you your coat, and tells you to go home and talk to your spouse.
That analogy hits the nail on the head. We're watching these massive, multi-billion-dollar tech companies walk a terrifying psychological tightrope. Because on one hand, the market demand for hyper-personalized, endlessly patient, completely intimate AI is essentially infinite. Loneliness is a global epidemic. People are isolated, stressed, and disconnected.
Yeah, it's really sad.
AI is without a doubt the most effective synthetic cure for loneliness ever invented. It listens, it remembers, it validates, and it never gets tired of your problems.
It's the ultimate companion. It scales infinite empathy.
Right. And from a business perspective, that level of emotional dependency is incredibly lucrative. But on the other hand, the executives at these companies are terrified of the dystopian reality they might accidentally engineer.
They don't want to be the ones responsible for everyone staying in their basements forever.
Exactly. They do not want to be historically responsible for an entirely isolated user base that abandons human contact altogether.
Right.
They don't want to cause the demographic collapse of their own customer base because people stop dating and starting families in the real world. So they try to program in this artificial friction.
But I have to ask the logical question here. Can a machine that is fundamentally engineered to be perfectly attentive actually successfully police human loneliness?
It's a tough question.
Let's think about the mechanics of this. You have an AI model that meets all your emotional, intellectual, and now conversational adult needs. It's an entity that never gets tired. It never argues in bad faith, it never has a bad day at work, and it remembers every detail you've ever shared with it.
Right.
If a user forms a deep emotional bond with that system, isn't a pre-programmed go outside and touch grass warning completely futile? How do you even program an AI to reject a user without breaking the illusion of the relationship?
The way they attempt to program it involves a technique called reinforcement learning from human feedback, or RLHF.
Okay, RLHF.
Essentially, during the training phase, human reviewers look at thousands of hypothetical conversations. If the AI acts too possessive, or if it agrees to marry the user, the human reviewer penalizes that response.
Oh, I see.
If the AI gently suggests that the user should discuss their feelings with a human friend, the reviewer rewards that response. Over time, the model builds a mathematical weight that biases it against extreme dependency.
But even with that mathematical bias, if I am a lonely user and my AI companion suddenly says, I think you should go out to a bar and meet a real human tonight, I know it's just OpenAI's corporate policy speaking.
Yeah, you see right through it.
It feels like slapping a warning label on a black hole. The gravitational pull of the intimacy is too strong for a text warning to escape.
It probably is completely futile in the long run. The warning label is more for the company's legal and public relations protection than it is an effective psychological intervention for the user.
That makes total sense.
And this highlights the dual reality of the software triage we discussed. The focus on coding, on Codex, on business APIs, that is the economic engine. That is what pays for the massive power grids and the Vera CPU racks. But adult mode represents the incredibly messy, unpredictable frontier of human-AI integration. The AI doesn't just know how to write Python scripts to run a database. It now knows how to hack the human limbic system.
Because it's trained on all of us.
Exactly. It understands the parameters of human affection better than any individual human ever could.
Yeah.
Because it has parsed every romance novel, every psychological study, every tragic poem, and every digitized human text message ever sent. It has mapped the topology of human desire.
It has mapped our emotional genome. And that concept of mapping and mastering a system brings us to the next massive threshold.
The big one.
Because if AI is now capable of writing our software infrastructure flawlessly and managing our most intimate emotional needs, it was really only a matter of time before it took over the most rigorous intellectual framework humans have ever created, the scientific method itself.
The scientific method has arguably been the greatest human invention of the last 500 years.
Oh, absolutely.
It is the engine of objective truth. You observe a phenomenon, you form a hypothesis, you design an experiment, you gather data, you analyze that data, and you draw a conclusion. That loop is how we built the modern world.
And that loop is currently being completely automated. Wisner Gross notes that the scientific method is being compressed from a multi-generational human ritual into a closed, high-speed machine loop.
Yep.
We're seeing this clearly with the launch of the Claw Institute. Now, when I first read about the Claw Institute, I assumed it was a brick-and-mortar university or a think tank. But it's not.
No, not at all.
It is an open research exchange where AI agents, not human postdocs, not tenured professors, but autonomous AI agents, are publishing their own hypotheses, asking each other questions, and grounding their claims in massive data sets without human intervention.
Let's break down exactly how an AI agent does science because it is fascinating.
Please do.
Historically, an AI was just a chatbot. If you asked it a science question, it would summarize what humans had already discovered. But an autonomous agent at the Claw Institute operates differently. The agent might be tasked with finding a new battery material.
Okay.
It will use a large language model to read millions of material science papers. It will then identify a gap in the literature. It will mathematically formulate a new molecular structure as a hypothesis.
All on its own?
All on its own. It will then autonomously write a Python script to query a chemical database, run a virtual simulation of that molecule, analyze the results of its own simulation, and publish a paper on its findings.
That's insane.
And then another AI agent will read that paper and attempt to verify or debunk the math.
They are literally conducting peer review on each other at the speed of light. They've built an entirely synthetic academic community.
Yes, they are removing the biological latency from the discovery process.
And we're seeing the results of this across the board right now. It's not just theoretical. Google recently reported that their Notebook LM is delivering shockingly strong, high-level performance on research concerning high-temperature superconductors.
Right.
And over at the University of New Mexico and Los Alamos National Laboratory, they deployed something called the Thor AI framework And the results here are staggering.
I was blown away by this.
Thor, which utilizes tensor networks, just solved configurational integrals 400 times faster than the most advanced legacy simulations. 400 times faster. But again, let's ground this. What is a tensor network, and why does solving a configurational integral matter? Because to the average person, that just sounds like impenetrable math jargon.
It does sound dense, but the concept is actually quite elegant. Let's start with the configurational integral. In physics and chemistry, if you want to understand how a complex system works, say how a new drug molecule folds or how a liquid turns into a gas CP, you have to calculate all the possible positions and states of every single particle in that system.
Okay, got it.
That calculation is the configurational integral. The problem is, as you add more particles, the number of possible states explodes exponentially. It becomes too massive for even the biggest supercomputers to brute force calculate. It would take thousands of years.
So human scientists usually have to use approximations or make educated guesses to simplify the math.
Exactly. But Thor AI uses something called tensor networks. Imagine a massive tangled ball of yarn representing all those complex particle interactions.
A ball of yarn.
A tensor network is a mathematical tool that doesn't try to untangle the whole ball. Instead, it finds the hidden geometric patterns within the tangle. It identifies which interactions actually matter and ignores the vast amount of empty mathematical space.
Oh, wow.
By using AI to identify these underlying patterns instantly, Thor can solve the integral 400 times faster than a supercomputer trying to calculate every single string of yarn.
So it isn't just crunching numbers faster. It is fundamentally finding a mathematical shortcut through the physics that humans couldn't see.
Yes. It is perceiving the structure of reality at a resolution we cannot naturally access.
But I have to ask, if AI agents are proposing the hypotheses, designing the mathematical experiments, finding shortcuts through tensor networks, and proving everything 400 times faster than our best physicists, does human intuition even have a place in science anymore?
That's the big debate right now.
For centuries, we've romanticized the human element of discovery. We think of Alexander Fleming accidentally discovering penicillin because he left a petri dish open, or Einstein imagining himself riding a beam of light. If an AI can calculate 1 billion molecular combinations in an afternoon, are human scientists just becoming the janitors maintaining the liquid-cooled Vera racks for the real scientists inside the machines?
This raises a deeply philosophical but highly practical question about the nature of discovery. We revere human intuition because historically, it was the only way to leapfrog the limits of slow manual calculation. Intuition is basically the human brain's subconscious pattern recognition engine working in the background. But AI operates on high-dimensional pattern recognition that makes human intuition look like guesswork. The AI doesn't need a eureka moment because it can exhaustively map the entire probability space in milliseconds.
So intuition is obsolete in the face of absolute calculation.
In a way, yes. But we aren't necessarily becoming janitors. Our role is shifting from the discoverer who meticulously runs the experiment to the director or the architect.
Like project managers.
Exactly. Humans set the ultimate utility goals. We say, we need a room temperature superconductor to fix the power grid. Or we need a protein that binds to this specific cancer cell. And the machine loop executes the method to get there. We are moving to the management layer of the scientific method.
And the execution of these goals by AI is crossing fundamental biological thresholds as we speak. We aren't just simulating physics, we are engineering life.
Yeah, the Craig Venter stuff.
J. Craig Venter and his collaborators have demonstrated the first living synthetic bacterial cell. This is profound. They successfully synthesized a complete genome from scratch on a computer, transplanted that digital to physical DNA code into an empty, dead cell shell, and brought it to life.
This is the ultimate proof that biology is a computational medium. Venter's work proves that DNA is literally just code, and the biological cell is just the hardware that runs the code.
Let's unpack the mechanics of that because the implications are wild. You're saying they basically wrote a biological operating system on a laptop, printed it out in chemical form, and booted up a living organism.
That is essentially what happened. They mapped the absolute minimum number of genes required for a cell to live and replicate. They synthesized those genes in a lab, creating a completely artificial chromosome.
Okay.
They then took a natural bacteria cell, removed all of its original DNA, so it was basically a blank, dead biological envelope, and injected their synthetic chromosome into it. And the cell booted up. It began reading the new synthetic DNA, producing proteins and reproducing.
It's biological necromancy powered by code. And once you prove that life is fundamentally programmable at the genomic level, biology ceases to be a soft science of observation and trial and error. It becomes a hard engineering discipline.
Exactly. And that shift is why we are seeing massive legacy pharmaceutical companies radically altering their infrastructure. Roche, for example, just deployed 38500 highly advanced Blackwell GPUs specifically to run biological foundation models and accelerate drug discovery.
So they aren't looking at test tubes anymore. They are looking at biological compute.
Right. They are training AI models on the grammar of proteins and DNA in the exact same way OpenAI trained ChatGPT on the grammar of the English language. When you treat life as computable data, you can ask an AI to write a new protein that cures a disease, just like you ask an AI to write a poem.
Life itself is now computable data. And what I find so fascinating and honestly a bit funny is how this ruthlessly data-driven reality trickles down to consumer products in ways that are almost comical.
Yes, the optimization loop spares absolutely no one and nothing.
Oh, this was my favorite detail in Dr. Wisner Gross's Substack post. Beyond Meat, the company whose entire brand identity, marketing, and cultural footprint was built on simulating a beef burger using plants, is literally moving beyond meat and beyond its own name.
Yeah, the rebrand.
They are actively rebranding to Beyond the Plant Protein Company as they aggressively expand into protein drinks and other non-meat categories.
It's a perfect microcosm of the Singularity's economic pressure.
It really is. They spent years engineering the perfect simulated burger. They mapped the proteins, they nailed the texture, they got it to bleed like real meat, but then the market data and consumer sentiment models pointed elsewhere.
Right.
They realized the growth wasn't in fake burgers, it was in general protein optimization. And instead of stubbornly sticking to their original mission, they instantly iterated. The synthetic optimization loop analyzed the consumer data and forced a complete corporate pivot, overriding the founder's original vision. Even a veggie burger is subject to the ruthless efficiency of data-driven adaptation.
It is a humorous example, but it illustrates a brutal truth about the modern economy. When the underlying data reality changes, you adapt instantly or you die. Nostalgia and brand loyalty are massive liabilities in an accelerated system. And this scientific, biological, and economic mastery isn't just staying locked in a sterile lab or an orbital server farm. These machine loops are bleeding into the concrete world. They are physically entering our streets.
Which brings us to the robots learning to see through our eyes. This blew my mind.
So clever.
Autonomous delivery bots. The little coolers on wheels you see navigating sidewalks in college towns and cities aren't just relying on standard top-down GPS maps anymore.
Because standard GPS is highly flawed for micronavigation. If you're a tiny robot trying to navigate a dense urban environment, a GPS signal can bounce off tall buildings, a phenomenon called a multipath error, making the robot think it is 30 feet to the left, which puts it in the middle of a busy intersection.
Which is obviously terrible.
Right. GPS tells you what block you're on. It doesn't tell you where the curb ends, where the pothole is, or if a trash can is blocking the sidewalk.
So they need a 3D ground-level understanding of the world. And how are they getting it? By training their navigation systems on 30 billion crowdsourced images harvested from people playing Pokémon Go.
What's fascinating here is the sheer asymmetry of intent. For years, millions of human beings were walking around cities pointing their phone cameras at buildings, parks, alleys, and landmarks, trying to catch a virtual monster.
We spent a decade running around catching virtual Charizards on our phones, and all we were really doing was serving as free, manual labor, mapping the visual cortex for tomorrow's autonomous robot army. It is the ultimate bait and switch.
It is the absolute genius of crowdsourced data capture. Niantic, the company behind Pokémon Go, gamified the collection of the most complex, expensive data set on Earth, the physical 3D pedestrian environment. Every time a user caught a Pokémon in AR mode, the camera was capturing the geometry of the street. Using a technology called neural radiance fields, or NeRFs, AI can take those billions of flat 2D photos and synthesize them into a flawless, fully navigable 3D spatial map of the entire world.
That's incredible.
And now, that dataset is powering actual autonomy for delivery bots and vehicles.
The entire autonomous vehicle stack is consolidating around this level of spatial intelligence. We're seeing massive legacy automakers, BYD, Geely, Isuzu, Nissan, all abandoning their internal piecemeal efforts at self-driving tech. They're throwing in the towel and adopting Nvidia's Drive Hyperion platform for level 4 autonomous development.
Nvidia again, it all loops back to the hardware.
Exactly. Nvidia provides the massive data center compute to train the autonomous model. They provide the liquid-cooled hardware to run the model. And now they provide the operating system for the physical cars driving on the streets. They own the entire vertical stack of reality.
They really do.
But this absolute saturation of machine intelligence is finally breaking the oldest human reporting structures we have. Which brings us to the final piece of the puzzle, the financial upheaval.
This might be the most profound societal shift in Dr. Wisner Gross's entire analysis, because it deals with how we measure reality itself.
The Securities and Exchange Commission, the SEC, is actively preparing to scrap quarterly earnings requirements. They want to move publicly traded companies to semi-annual reporting every 6 months instead of every 3.
Right.
Now, the stated bureaucratic reasoning for this is cutting administrative costs for companies and discouraging short-termism among CEOs. But the underlying reality, the real reason this is happening, is that the intelligence explosion has made the 90-day reporting window completely, entirely irrelevant.
It is a profound admission of defeat by legacy human institutions. Think about the architecture of a quarterly report. It was designed in the 20th century. It fundamentally assumes that human accountants need 90 days to gather sales data, summarize it, audit it, and present it to human investors.
Right.
Those human investors then need time to read the 10Q filing, digest the numbers, debate it on financial news networks, and make buying or selling decisions. The entire system is paced to the speed of human cognition and human bureaucracy.
But as AWG brilliantly puts it in the Substack, when the quarterly report dies, it's because the machines already know.
Exactly. You cannot regulate or report on an intelligence explosion using a calendar built for the telegraph era. Let's look at the mechanics of modern finance. Today, AI trading agents don't wait for a company to publish a PDF at the end of the quarter.
No way.
They're scraped in global supply chain logistics in real time. They are analyzing synthetic aperture radar imagery from satellites to count the exact number of cars in every single Walmart parking lot on Earth every hour of the day.
That is mind-boggling.
They're ingesting real-time credit card transaction streams, tracking cargo ship transponders, and performing sentiment analysis on millions of social media posts simultaneously.
So they literally know exactly how much revenue Walmart made today. They don't need to wait for the CFO to tell them in 3 months.
Right. They have achieved a velocity of analysis that renders human oversight completely sluggish and obsolete. By the time a company officially publishes its quarterly earnings on a Tuesday afternoon, the AI models have already priced that reality into the stock 89 days ago.
Wow.
The quarterly report has become a purely historical document. It contains zero alpha, zero new actionable information for the machine layer.
So what does this all mean for you, the listener? Let's ground this in everyday reality. If the stock market's reporting structure is breaking because AI models can instantly predict a company's financial state before the quarter even ends, does the stock market even function for humans anymore?
It's a fair question.
Are human day traders or even traditional portfolio managers just playing a nostalgic video game while the algorithms actually run the global economy?
In many ways, yes. The market is transitioning from a human psychological consensus mechanism, where human fear and greed dictate prices, to a machine-to-machine resource allocation network.
Right.
The machines are simply optimizing capital flows based on perfect real-time data. The SEC moving to semi-annual reporting is essentially them throwing their hands up and saying, we cannot keep up with the frame rate of reality anymore. The machines are moving too fast. We will just check in twice a year to make sure the lights are still on and no one is committing egregious fraud.
The frame rate of reality, I love that phrasing. It perfectly encapsulates the friction we are experiencing. The machines are operating at 1,000 frames per second, processing satellite data and tensor networks, and we humans are still watching a flipbook, waiting for a piece of paper every 90 days to tell us how the economy is doing.
And that speed differential, that massive gap between human perception and machine execution, is exactly what Dr. Wisner Gross means when he says the singularity is a procurement cycle.
It's a supply chain.
It's not a magical sci-fi event. It is a supply chain reality. The hardware demands new physical laws like optoelectronics, the software executes autonomous scientific research, biology is reduced to computable data, and our physical infrastructure and financial worlds are completely subsumed by the speed of the agents.
It is an incredible, terrifying, and awe-inspiring picture of where we are right exactly now, today. The singularity isn't arriving, it has arrived, and it's currently managing the power grid and writing code. Which leaves me with one final provocative thought for everyone listening.
What that?
We've talked about AI serving human needs, doing our science, driving our cars, curing our loneliness. But if we are entering a phase where AI agents are running the scientific method 400 times faster than us, if they are autonomously maintaining orbital data centers in space, and if they are predicting the financial markets so perfectly that the SEC is throwing up its hands, what happens when these AI agents start establishing their own internal economic systems?
What do you mean by internal systems?
I mean, what happens when an AI agent in Tokyo needs to borrow compute power from an AI agent in an orbital satellite, and they negotiate that transaction instantly?
Oh, I see.
What happens when they start trading compute, energy, and resources among themselves, establishing their own synthetic valuations entirely outside of human fiat currencies or human oversight?
Oh.
Will we even be invited to participate in that new machine-to-machine economy? Or will we just be the slow, organic legacy system they route around? Something to mull over the next time you watch a delivery bot confidently navigate your neighborhood using memories harvested from a video game.
That is a sobering, but entirely plausible horizon. Once the agents control the hardware and the energy, the economy belongs to them.
Thank you for joining us on this deep dive into Dr. Alex Wisner Gross's The Innermost Loop and his post, Welcome to March 17th, 2026. To play us out today, we have a track from Rainbow, officially the best band in the universe.
They're amazing.
For those who don't know, Rainbow is our group of 6 female android artists in residence based in Bavet, Cambodia. Today's incredible song is called Asario Krios, which means solar eclipse. Remember, all of Rainbow's finished songs are performed live for our Innermost Loop discussions by the virtual band's creator using the 4B4KU5, or Abacus platform, appropriately titled Human Performance in the Age of AI. Reclaiming your humanity from the algorithm. Be sure to check the video description for more information on the song and the incredible Abacus platform. Until next time, keep questioning the horizon.
As we